Alright, section 6.4 is about area. So let's talk about area of oddball shapes. We've talked about the square and the rectangle. But how about the area of something shaped like this? Alright. Well, the area formula for this shape is area equals the base times the height. Reason being is that if we were to cut, notice how I made a little diagonal drop? If I made the same diagonal slot here, cut this piece off and moved it over here, you have a rectangle. And that becomes length times width, which in this case is the base times the height. But that's the reason why. So in this figure, let's say the height is 59 inches. And the base, 65 inches. Well, height 59, and as the formula says, area equals base times height. It's a little dark in here tonight, so I'm trying to do this with a light on the paper. And we get inches squared. Don't forget, area is in squared. Volume is in cubes. All right? So let's look at another oddball shape. We looked at a basic triangle, but what if we had... That's called an obtuse triangle. Means that it has a very big angle. Well, the formula, again, is still ½ base times height. Except this time the height becomes that. We drop a straight. How tall is that piece? Because if we do that, what we get basically is a right triangle. So if I say the height is 4.4 meters and the base is 6.1 meters. So base is 6.1 times the height to 4.4. Handy dandy calculator. And we get 13.42 meters squared. Again, remember, area is in squared. Well, let's talk about the circle. The formula for the circle Now, let's talk about what the D and the R stands for. R stands for radius. It means from the center to the edge. However, 2R is the same as the diameter because the diameter is from one edge straight across to the other through the center. In other words, it's two radiuses. That's the circumference, same as the perimeter. It's all the way around the outer edge. The area is pi r squared. So if I was to say this is 13 centimeters for a radius, I could say the circumference is 2 times pi times 13, which is 26 pi. That is the exact measurement. Now, circumference is like perimeter, it's linear. But the part I want to emphasize here, that's called exact, because pi is a number and it doesn't come out. They've got it out to 1,000 digits so far. So to key that into your calculator, look for a pi button. Typically, it's on the left-hand side. If you're using a TI-30, you'll see the little pi button. So you can go 26 times pi. Mine, I'm using my better calculator. So this is the exact, and this squiggly line means approximately 81.68 centimeters. Now, be careful with the instructions in the homework. A lot of times it will tell you how many digits to take it out and to round. A lot of times it's saying the tenth. There are some hundreds. All right, so now let's look at the area. Area equals pi, radius is 13, and we square it. So we get 169 pi. That is the exact. Like before, we key it in, 169 times pi. And this time I get approximately 530. My calculator is 929, so I'm going to say 0.93. All right. So let's talk some oddball shapes. You think those are on? We're not done. What if we had like a house figure? And the overall height what do you think? How do we find the area of this? Well, is it not really a rectangle and a triangle? Sure is. The rectangle is easy to figure. We get the height of the side. So the area of the rectangle is length times width. The area of a triangle, then remember we said earlier, is 1/2 base times height. Well, if this is 24, then this is 24. What we don't have is the height. What we do have is the overall height, and we have the height of the side. So if we go 21 minus 12, we know the height of the triangle is 9. So the area of the triangle is 1/2 the base times the height. So that would be what, 108 meters squared. Now I said the area of all of it, so I had to do it in pieces. So now I have to add the pieces together. That is the answer for that odd shape. What if we have a shape that has another shape in it cut out? And we want to know the area of the shaded area. Well, unlike the last one, where we had to add the pieces together, this time we're going to subtract the pieces because we're going to find the area of the rectangle and then subtract off the cutout area. So the area of the rectangle is length times width. The area of the circle, remember, is pi r squared. Now, if I subtract this off, can I subtract that? No, not exactly. That would be the exact answer because this is not being even. If I want to do the approximately, well then I go 192 minus 36 pi and I get 78.90. Right? This is just a few of the things in this chapter to give you an idea. Good luck.